We're at day 60 here. Today I'm going to introduce to you L'Hopital's rule. L'Hopital's rule is a super handy method for solving limits. So we talked about limits at the very beginning of the year, but there's an easier way to evaluate limits when they come out in certain forms. Okay? So first thing to know about L'Hopital's rule is when we can use it. So L'Hopital's rule can be used in anytime we have zero. Anytime we have 0 over 0. Okay. We can also use L'Hopital's rule whenever we have plus or minus infinity over plus or minus infinity. Okay? So those are the times when we can use it, and it's kind of a shortcut to getting the right answer. Now, sometimes we need to use L'Hopital's rule on the multiple choice. Sometimes we need to use it in the free response section. You need to be very careful about using L'Hopital's rule in the free response section, because you must show that the case is a 0 over 0 case, or a plus or minus infinity over plus or minus infinity. Okay? You have to show that that is the case, and then you have to say, using L'Hopital's rule, you get the certain answer. Okay? I'll kind of highlight that a little bit in a second. So what we do, if we have a limit where we end up with 0 over 0, or infinity over infinity, which is like most of the time, right? You can use L'Hopital's rule. What we do is we do the derivative of the top function and we do the derivative of the bottom function, and then we reevaluate. This is not the quotient rule, okay? We're not doing the quotient rule. You're simply deriving the top and the bottom. So let's say we have a limit as x goes to a, right, of some function f of x over some function g of x. Okay? So what happens is, let's say we plug in a. So we plug in a and we do f of a over g of a, right? And this makes 0 over 0. That's one of the cases that can be used, that we can use L'Hopital's rule. What we want to do then is we'll do the limit as x goes to a. We'll do the derivative of the top and the derivative of the bottom. Then we'll plug in a. But now we're plugging into the derivative, right? And that might give us our limit answer. Right? If we get 0 over 0 again, we can just keep doing L'Hopital's rule over and over again until it works. Okay? Let me show you an example. I'm going to show you these examples like they are on the free response and the kind of notation that we need to make sure that we have. Okay? So let's look at a limit that is very similar to one that you would have had a test that you should have been able to solve back in August. So here's the problem. Okay, so if I gave you this problem back in August, the first strategy we do is we plug in -5 to see what happens. When we plug in -5 for x, what do we get on top? Well, we get -5 squared, that's 25, minus 20, minus 5. And on bottom we get positive 25 again. Now we get minus 35 plus 10. Well, 25 minus 20 is 5. 5 minus 5 is 0. And on bottom, 25 minus 35 is -10. -10 plus 10 is 0. So we get 0 over 0. That doesn't mean the limit does not exist. It means there's likely a hole in the graph at that point. Right? Now think back to how we would have solved this in August. Well, one of our strategies was to factor, right? Excuse me. So you would have factored the top, and you would say, okay, that factors into, what two numbers multiply to negative 5, but add to 4? That would be positive 5 and negative 1, so those will factor to x plus 5 and x minus 1. What numbers multiply to 10 but add to 7? That would be x 5 and 2, so we get x plus 5 and x plus 2. And then you would have canceled out the x plus 5s. That was what was giving us the problem. And now we plug into the top and we get negative 5 minus 1 over negative 5 plus 2. Negative 5 minus 1 is negative 6. Negative 5 plus 2 is negative 3. And we would have gotten 2 for an answer. And that worked fine for us. But sometimes L'Hopital's rule is easier. Okay? So let me show you how I evaluate this using L'Hopital's rule. Let me just recopy this problem. Okay, we still have to show that when we plug in, right? So evaluating when we plug in, we get 0 over 0. Okay? We need to show that it's making 0 over 0. Then we have to say the phrase, using L'Hopital's rule. Right? What we're going to do is we're going to reevaluate this limit by doing the derivative of both the top function and the bottom function. Well, the derivative of the top function is 2x plus 4. Right? I'm just doing the derivative of x squared plus 4x minus 5. And then I'm going to do the derivative of the bottom, which is 2x plus 7. And now I'm going to reevaluate this limit. 2 times negative 5 is negative 10. Negative 10 plus 4 is negative 6. 2 times negative 5 is negative 10. Negative 10 plus 7 is negative 3. And I get to my answer of 2 without having to do factoring. Okay? Now on the test, you can do it either way, right? But if it was multiple choice, right, you don't have to write on your multiple choice test that you're using L'Hopital's rule. But if it's free response, you do. You have to show that it's 0 over 0, right, to show that you can use L'Hopital's rule. L'Hopital's rule only works when in those special cases. Okay? Let's take a look at another one. So that was one that you could have easily solved either way, although I think it's a little bit easier to use L'Hopital's rule. Let's try one that's a little bit harder to solve without L'Hopital's rule. Okay, so here's a problem. The limit as x goes to 0 of x over sine x. Okay, this is a little bit more challenging here because I don't really like the strategy for proving this. You can prove it without using L'Hopital's rule, but it's pretty difficult, right? We'd have to use some crazy stuff here. But what happens when we plug in 0? Well, the top obviously makes 0. Over sine of 0 we know is 0 as well. So anytime we get 0 over 0, we can use L'Hopital's rule. So we just need to write that down that we need to show this, right? We need to show 0 over 0, and then we have to say using L'Hopital's rule. Okay, using L'Hopital's rule, we're going to do the limit as x goes to 0. Now we're just going to do the derivative, we're going to do the derivative of the top and the derivative of the bottom. Note, this is not the quotient rule, right? I'm not following that pattern. I'm simply deriving the top, I'm deriving the numerator, and I'm deriving the denominator that I'm plugging back in. Well, what's the derivative of x? The derivative of x is 1. What's the derivative of sine x? Well, that would be cosine x. Now we can plug in 0 and see what happens. Well, there's nothing to plug in on top, so it's just a 1. What is cosine of 0? Well, cosine of 0 is also 1. 1 over 1 equals 1. And I can solve the limit very easily. just remember, you don't have to write that using L'Hopital's rule if it's a multiple choice question on the AP exam. But you do need to both show that L'Hopital's rule will work, so either 0 over 0 or infinity over infinity. And you need to state that you're using L'Hopital's rule. Okay? I'm going to cut it there for today. We'll look tomorrow at some of those local linearization problems again, but I also want to show you some limit problems that we can solve very easily using L'Hopital's rule. That's it for today. Make sure you take good notes on this. I'll definitely be checking them tomorrow. See you guys. 2 chains. Bye. Bye.